grow in Zambia and the livestock.
Look at our algebraic expression. Good afternoon, learners. It's another mathematics session for grade 8, and you are with me, Mr. Banda R.D. Before we start, in case you have got any question or you need clarification, you can call the number 0977 728000. In case you would like to enroll with GMF online, we have the number on the screen there. You can contact for more details. Yesterday's lesson, we are looking at simplifying algebraic expressions, and we looked at addition, subtraction, multiplication, and division. By now, I expect you learners to understand or be able to solve questions related to that. Before we go to our next lesson, let's go through on one of the questions that I gave you as a task. I'll read out the question that I gave you, the first question. Simplify each of the following expressions. Simplify each of the following expressions. And I gave A, B, and C. So I thought I will pick C. We work it out together. And C is 12 mn plus 4m squared n minus 3mn plus 2m squared n. This is the expression that was I gave you. 12mn plus 4m squared n minus 3mn plus 2m squared n. If you check this expression here, you will notice that it has got 4 terms. 1, 2, 3, 4. It has got 4 terms. Now, when you are dealing with such expressions, first thing you are supposed to do, you collect like terms together. You collect like terms together, and we have 12mn. If we check here, you discover that this one, negative 3mn plus 4m squared n plus 2m squared n. So we have collected like terms together. We can now work them out. The first term that we have here is 12mn. It has a coefficient of 12. And the second term that we have here, we have a coefficient negative 3. Therefore, we do have 12 minus 3m. So 12 minus 3m, it gives us 9. Then we return the coefficient as they are, mn. Then we come to the next part. We also have the like terms here. 4m squared plus 2m squared n. So if you check, the coefficient here is 4 and the coefficient here is 2. So we add the coefficient 4 plus 2, and it will give us 6. Then we return the variables as they are. So 4 plus 2, we get 6. Then we return the variables m squared n. So we do have m squared n as our final answer. If you check here, you notice that these are unlike terms. Therefore, they cannot be added or they cannot be simplified any further. So we end the answer here. So this is the answer I was expecting from you learners. We proceed, we go to our next part. I gave you 2 questions. And the next question we have was, we simplify the following expression, and this one is under division. We do have negative 21pq divided by negative 3p squared q. This is another expression that we have, and we have been taught to simplify this one. Remember, this one can also be written as negative 21pq divided by negative 3p squared q. We can further write this one as negative 21 multiplied by p multiplied by q over negative 3 multiplied by p. Remember, it's p squared. So p multiplied by p multiplied by q. If you check the numerator here and the denominator here, you notice that there are some like terms. Therefore, we are going to cancel them out. So we do have q in the denominator here, we cancel it out, and the numerator here, there's a q, we cancel. We check, we do have the p here, we cancel, and the p here, we cancel. What remains now is negative 21. And down here, which is the denominator, we do have negative 3 multiplied by p. Of course, we know that negative 3 can go into negative 21. So negative 3 into, of course, negative, it will cancel, negative, it will cancel. So 3 into 21, you get 9. Okay, before we proceed, I think after cancelling, we do have negative 21 over negative 3 multiplied by p. This is what we have. Let's cancel the negative here, we cancel the negative here. Now, what has remained is 21, and the denominator here, what has remained is a 3 multiplied by p. So, we know that 3 can go into 21, and 3 into 21 is 7. So our final answer will be 7 over p. This is the expected answer. This is the expected answer. Let's proceed to our next part. Today we look at expanding algebraic expression. There's an introduction of expanding. What do you understand when you say something has been expanded? To expand something, what do you understand by that? I would say if something has been expanded, probably it has been changed from being a smaller thing to a larger thing. So in this case, we'll be dealing with expansion of algebraic expressions. And my statement here is saying to expand an algebraic expression of the form k in brackets a plus b, every term in the bracket is multiplied by the number k in front of or outside the bracket. This is called the distributive law of multiplication over addition. So we use distributive law to eliminate the brackets. So we have an example here. K in brackets A plus B. If you check this expression here, we do have the two terms inside this bracket. And these terms, we have got the first term A and the second term B. Now, for us to expand, of course, what we're going to do, we're going to distribute, meaning we're going to multiply the number that we have here as K. We multiply K to each and every term in the brackets. So we can do this by distributing K multiplied by A. It will be K multiplied by A plus K multiplied by B. So what we have done here, we have done the distribution. Multiplication has been distributed in this case. So we end up having KA plus KB. Similarly, KA minus B. We can still do the same here. We do have the number outside the bracket here, A minus B. We can still distribute this K by multiplying each and every term inside the brackets. Therefore, it will be K multiplied by A minus K multiplied by B. We end up getting KA minus KB. So in this case, multiplication has been distributed over subtraction. Whilst the top part here, multiplication has been distributed over addition. Let's look at the first example. Our example 1. Our example 1. Our example 1 saying simplify. Simplify A 5 open brackets 3A plus 2B cross brackets plus 2A plus 2B. This is the expression we have here. 5, what is inside brackets, we've got 3A plus 2B plus the outside the number here, we have got A plus 2B. So, in this case, we are going to distribute, meaning we are going to multiply 5 by each and every term in this bracket. So we start by 5 multiplied by 3A plus 5 multiplied by 2B plus, we come to the second part here. It will be 2 multiplied by A plus 2 multiplied by 2B. Have the caller. Yes, hello. You are through to mathematics session grade 8. Your name, please, and where are you calling from?
Gertrude Remember.
Yes, Gertrude.
Calling from Western Province.
Please, Gertrude, you are through.
Yeah, I'm calling to find out.
Yes, please.
Yeah, I just started watching the channel today, so I wanted to find out if these other grades, they are also having their own sessions, or there's a different channel.
Come again.
I'm finding out if there's a different challenge for these lower grades, because there I'm just seeing the grade 8 only.
Lower grades like at primary level?
Yeah, we have the grade 7, the grade 6.
Okay. Actually, that program will be coming probably next week. Keep on watching. You'll be informed. Yeah. But we do have other sessions, that is for sessions for the grade 10s and grade 11s. I think on the screen there you can check that there's the number for inquiry. Probably try to contact those lines, they'll be able to help you.
Okay, thank you very much.
You're welcome, madam.
Yeah, we'll keep waiting.
We proceed, we do have an expression here. Of course, we are going to distribute, of which we have done, 5 multiplied by 3a plus 5 multiplied by 2b plus 2 multiplied by a plus 2 multiplied by b. We have seen that this 2 is being distributed to each and every term inside the brackets. Now, what we have done here, you can see that the moment you introduce a multiplication, you multiply the number here by each and every term inside. It shows that we have eliminated the brackets, and you can see that the second step here, you cannot see any brackets here. So we proceed. 5 multiplied by 3a, it will be 15a, plus 5 multiplied by 2b is 10b, plus 2 multiplied by a is 2a, plus 2 multiplied by 2b is 4b. Now, where we have reached here, we have to be very careful. You have to check which ones are right terms. Then we have to pair them. So you see that here there's 15a, there's also 2a. We pair them together. 15a plus 2a plus 10b plus 4b. I have a caller. You are through to mathematics session. Your name, please, and where are you calling from? Okay, we'll proceed. So we have paired like terms together. We have 15a plus 2a. We have coefficient 15 here and coefficient 2 here. So it will be 15 plus 2. We end up getting 17. Then we retain the variable here as a. Plus, the next part here, you notice that we do have like terms. So it will be 10 plus 4, we end up getting 14. Then we retain the variable as b. Then this is our final answer. Where we have reached, it cannot be simplified any further, as we know that they are unlike terms. We end here. This is our final answer. Let's go to the next part as my second example. As b, 5 x plus y minus y minus 2x. This is our second expression, and we have been told we simplify this one. Of course, we are going to use the same law as distributive law here, meaning whatever that is in brackets here will be multiplied by 5. Even in this side here, whatever that is in brackets will be multiplied here. There's a negative 1. So we start. It will be 5 multiplied by x plus 5 multiplied by y. Coming to the second part here, remember here, for us to have these brackets, there's a negative 1 here. So it will be negative 1 multiplied by y. Again, it will be negative 1 multiplied by negative 2x. Hope you are following. There's a number here, negative 1 here. So we distribute, meaning we multiply negative 1 by each and every term inside these brackets. So it will be negative 1 multiplied by y. Again, negative 1 multiplied by negative 2. So we proceed. It will be 5 multiplied by x. It will give us 5x plus 5 multiplied by y. It will give us 5y. Negative 1 multiplied by y. It will be negative y. Then we do have negative 1 multiplied by negative 2x. Negative, negative, it will cancel out. It becomes positive 2x. We have reached this stage. We have to check and correct like terms together. So we do have our 5x here plus 2x plus 5y minus y. So we have paired like terms together. We have, of course, a coefficient here 5 and a coefficient here 2. So it will be 5 plus 2, 7. We retain the variable x. We come to the next part here. It will be 5y minus y. We end up getting 4. Remember, there's a negative 1, so it will be 5 minus 1. Here, there's a negative 1. So 5 minus 1, we get 4. So it will be plus 4y. This is our final answer. Where we have reached, there are no like terms. It cannot be simplified any further as our final answer. Hope you are coping, learners. Remember, whatever that you are given, whatever that is given to you, as long as there's something in brackets and there's a number outside or in front of brackets, make sure that that number must be multiplied by each and every term inside the brackets. Let's proceed. Let's go to the second part. Our second part we are going to look at today, we'll look at factorizing algebraic expressions. Factorizing algebraic expressions. This is our next part we are going to look at. What is to factorize? To factorize is the opposite of expanding. To factorize is the opposite of expanding. We can have this term here as 3x plus 12 is equal to 3x plus 4. Remember earlier on, when you are trying to do, of course, when you are trying to expand, this was the situation here. 3x plus 4. You have been told, can you expand this one, this expression that we have? Remember, we have the number out here, out of the brackets, and the terms inside the brackets here. What we used the distributive law of multiplication. Now, so meaning we used to do, we multiply 3 by each and every term, of which we do this one, it will be 3 multiplied by x plus 3 multiplied by 4, which will be 3x plus 12. So you can see now, of which we are getting back to this form. That's why I'm saying factorizing is the opposite of expanding. Now, when it comes to of course, expanding here, a question can be asked in this form here. Say 3x plus 12, and you have been told to say expand this expression. To expand this expression, we look for the highest common factor. We look at the highest common factor. So in this case here, which one is the highest common factor? 3x plus 12. You notice that 3x plus 12, the highest common factor, it will be abbreviated as HCF. The highest common factor will be 3. Now, when you're looking for the highest common factor, we're looking for the number that can go into each and every term here without leaving any remainder. That is the highest common factor. So we are looking for 3 because we know that in the first term that we have here as 3x, 3 can go into 3x. and without leaving any remainder. 3 can also go into 12 without leaving any remainder. So we factor out 3 as 3, meaning we're going to divide the 3 in each and every term here. So meaning 3 into 3x, what remains is x, plus 3 into 12, what remains is 4. So this is what we have done here as factorizing. We're trying to factorize this term. Let's do the first example. So this will be our example 2. Our example 2 is saying factorize the following. A for x plus 6. This is our first expression that we have. This is our first expression that we have. We have been told to say factorize 4x plus 6. The first thing when you have been told to factorize, you have to identify which one is our highest common factor, or we'll look for our highest common factor. So if you look at this expression, and that highest common factor must be divided into each and every term here without leaving any remainder. So in this expression that we have 4x plus 6, our highest common factor, which I will abbreviate it as HCF, highest common factor, will be 2. So we bring it down, it will be 2, open brackets. We know that 2 can go into 4 without leaving any remainder. So 2 into 4, it will be 2, then x plus 2 into 6, it will be 3. So this will be our final answer. We have done the factorization here. We have factorized this expression and we end here. It cannot be reduced any further. Let's go to our second example under this. Hope you have copied this part of the questions. Question B is 6y squared minus 7y. 6y squared minus 7y. What we have done in the first place here is to still apply even in the second expression that we have. We have 6y squared minus 7y. If you check this expression, we have to look for the highest common factor. Which one is the highest common factor? Remember, we do have the two terms here, the first term and the second term. If you check, our highest common factor here, HCF, is 1. So we are going to factor out y, open brackets. We know that now we can divide y into y squared. So we bring our coefficient the way it is. So y into y squared, meaning y into y squared. What we are saying here is y squared over y, which is the same as y multiplied by y over y. So y will go, y will go. What remains is y. Minus 7y divided by y. Y will go, y, what remains is 7. This is our final answer. So I did mention earlier on to say, when you're dealing with factorizing algebraic expression, it's the opposite of expanding. Because if you'd like to expand, you just multiply this back and you still get back to the original expression. Let's do our last example for today. Let's do our last example for today. 5x to the power 3 minus x squared. This is our expression that we have. We'll do the same way. We're going to identify which one is our highest common factor. If you check, we have got two terms, the first term here and the second term here. 5x to the power 3 minus x squared. You notice that our highest common factor in this case, our highest common factor is x squared. Because we know that x squared can go into each and every term here without leaving any remainder. So it will be x squared in brackets. We do have this one as 5x to the power 3 divided by x squared, which will be 5 multiplied by x multiplied by x multiplied by x divided by x multiplied by x. What do? We cancel this x, we cancel this x, we cancel this x, we cancel this x. What remains is 5x. So that will be our value here as 5x. We come to the second part. We'll do the same. We know that we have got x squared over x squared. This can also be written as x multiplied by x divided by x multiplied by x. You will notice that they will all cancel out. And what remains is a 1. So it will be minus 1. So this is our final answer. Learners, this is what we have tried to look at today. We have looked at expanding algebraic expressions and factorizing. Therefore, I've got a work that you're supposed to do over the weekend. You can copy from here. This is your task for the weekend. The first question says simplify a 2x plus 4x plus y b 2x plus 3y minus x minus 3y. Our second question is saying factorize a 8m squared minus 4m b 3xy plus 6x squared. And our last question, oh, this is the last question, okay. So you can try out these questions over the weekend in case you have got any challenges or maybe you need clarification. The number is there, 0977 728000. And we'll give you a feedback. Learners, the only secret I can give you when it comes to mathematics, you are required to practice every day. I know you do have different subjects, but you are required to practice mathematics every day. Have at least 30 minutes or 45 minutes to go through these questions. I can tell you, you're heading for a distinction. Thank you so much for your time. Hope you have copied these questions. Until next time, you have been with me, Mr. Banda Aradiu. Until next week, see you.
These are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
Good afternoon, class. Welcome to grade 8 English lesson. In today's lesson, we're going to look at reflexive pronouns. Our topic for today is reflexive pronoun. Okay, so on this topic, during our discussion for today, we must be able to use reflexive pronouns to complete sentences, and also we must also be able to construct sentences using reflexive pronouns. Okay, so the topic is on pronouns. Under pronouns, we've got two different types of pronouns. We have got possessive that we looked at, but today we're going to look at reflexive. Okay, so our topic for today is reflexive pronoun. We defined what a pronoun is last time when we had a discussion, and you can define a pronoun as a word that replaces a noun in a sentence. So a pronoun is a word that replaces a noun in a sentence. I'll give you an example of a pronoun. Okay, here is an example of how we use a pronoun in a sentence, how we change from a noun to a pronoun in order to avoid repetition. The reason why we use pronouns in a sentence, it's because we are trying to avoid repeating the noun. So I'll give you an example. Okay, I've got Martha is late. Okay, then I'll say Martha is late because she was cooking. Okay, so this sentence has got two words that we need to identify. We have got a noun and also we have got a pronoun. So we said a pronoun is simply used to replace a noun in a sentence to avoid repetition. So this noun Martha has been replaced with the pronoun she to avoid repeating the noun Martha in a sentence. So therefore, the pronoun in this sentence is the she. So she is what is an example of a pronoun. Okay, I was just giving you a guide, a recap, a revision of, so that you understand what a pronoun is. But today's topic, we're looking at the reflexive pronoun. Reflexive pronoun, a reflexive pronoun is a noun which refer back to the subject. Okay, a reflexive pronoun is a pronoun. A reflexive pronoun is a word that will refer you back to the subject. Every sentence has got what is known as the subject. A sentence that you construct must have a subject. So this subject is going to be replaced by a reflexive pronoun. And we're saying this reflexive pronoun simply refers back to the subject. Okay, we'll look at this example. This example. She paid for the protest. Okay, she paid, I would say, she paid for the book. Okay, in this sentence, we must add a reflexive pronoun so that we refer it back to the subject. Okay, so the subject of the sentence in this case is the she. Whom are we talking about? We're talking about the she. Okay, so to add a reflexive pronoun to this sentence, we're going to say she paid for the book herself. Herself. Okay, so the word herself is what we call reflexive pronoun. So the word herself is what is known as a reflexive pronoun because it is taking us back to the subject. A reflexive pronoun which is taking us back to the subject. Okay, that is just an example of a reflexive pronoun. Okay, so to form a reflexive pronoun, you simply add self or selves. Okay, you simply add self or selves to a pronoun. Then when you add this self or selves to a pronoun, the word that you come up with is known as a reflexive pronoun. Okay, let us look at this example. Her. Her is a pronoun. Okay, so we're adding the word self. We're adding self to the pronoun her so that it changes to a reflexive pronoun. So when we add self to a pronoun her, it will read herself. Okay, and we say it. Okay, and the reflexive pronoun self, the word self, is added to a pronoun when we're talking about plural. Okay, when you use self, it means we're talking about singular. Sorry, when you use self, it means we're talking about a singular pronoun. So usage of self is used to describe a singular singular, one. Okay, so when you use selves, it means you're talking about more than one. So this one becomes the plural. Are we together? Okay, so I'll give you some examples of some sentences where we're going to add reflexive pronouns. There are a lot of reflexive pronouns, but I'll give you a few examples. Remember, in English, what is important is constructing sentences. So we're going to construct sentences using the reflexive pronouns. And the examples I've given of reflexive pronouns are one, you can say herself, or you can say himself. Okay, that is now singular. So you can say them, selves, because they are more than one. Okay, these are examples of how you change a pronoun to a reflexive pronoun, taking it back to the subject. Okay, here is an example. I'll write a few examples on the board, and we're going to add the suitable reflexive pronoun. We're going to add the suitable reflexive pronoun. Okay, as our lesson is going on, we have got a number there to call. In case you want to construct a sentence using a reflexive pronoun, please feel free to call and construct one. Or in case you want to clarify on the reflexive pronoun, when to use the reflexive pronoun, you can please call on 0977 72 8000, 0977 72 8000. Here are some examples. Okay, examples will require us to add or say use reflexive pronoun to complete the following sentences. Example number one, question number one, she cleaned the house all by. She cleaned the house all by. Then we're going to add a reflexive pronoun. Another question, you did well in the exams. You must be proud of. You did well in your exam. You must proud of. Number three, she really wanted to see the man killed, so she paid murderers. She really wanted to see the man killed, so she paid the murderers. Okay, another example, I will come to your place. I will come to your place. Number four, I will call you. So number four would say, I will. Okay, so these examples, we are supposed to add a reflexive pronoun to take us back to the subject. We are supposed to add a reflexive pronoun to take us back to the subject. Example number one, she cleaned the house all by herself. So here we have got a pronoun which is the she. So to this pronoun, we are simply going to add either self or selves. Okay, when we say she, we are talking about one person. Therefore, we are going to add the self to this pronoun, and it will read, she cleaned the house all by herself. Okay, she cleaned the house all by herself. Herself is a pronoun which has replaced the noun she to avoid repetition in a sentence. Example number 2, you did well in your exam. You did well in your exam. You must be proud of. Okay, you. The noun in this example is the you. So we are changing this noun to a pronoun and we are adding self because it is one person. You did well. When talk about you, it is one person. So we'll say, you did well in your exam. You must be proud of yourself. You must be proud of yourself. Okay. We have added a reflexive pronoun. This person, self, is referring us back to the subject, which is the you. Okay, herself, we're talking about this person. It is taking us back to the subject. Example number 3. I will come to your place. I will come to your place. When you talk about I, you're talking about yourself, an individual. Okay, so we're going to replace this noun with a reflexive pronoun. I will come to your place myself. Myself. Okay. Example number 4. I will call you. Still remains myself. Okay, myself, I'll call you myself. I'll call you myself. Okay, that is how you change to reflexive pronoun. You change a pronoun to a reflexive pronoun. So this is a pronoun and it has been replaced by a reflexive pronoun herself. So the pronoun you has been replaced by the reflexive pronoun yourself. Okay, I is replaced by myself. Just like here, I has been replaced by myself. Okay, I'll still give you more examples. As I am writing examples, feel free to call. You can call or SMS on that number 0977 72 8000. 0977 72 8000. Okay, another example. Don't worry about this. I will fix it. Don't worry about this. Don't worry about. I have to take this call. Hello, good afternoon. Hello, good afternoon. Okay, I'll continue. Don't worry about this. I will fix it. Fix it. Number two, the money will be ready by tomorrow. I'll bring it to you. The money will be ready. We'll be ready. By tomorrow. I will bring it. Okay, number three is we're going to say, he never spoke through a lawyer, dash spoke in quotes. He never spoke through a lawyer. dash. He never spoke through the lawyer. He never spoke through the lawyer. Dash spoke in court. Dash spoke in court. You can as well construct sentences and rewrite them, and then you find the correct reflexive pronoun to use. Okay, so number 4, you don't need to do it. You don't need to do it that. We will do it. We will do it. You don't need to do it. Okay? You don't. Don't need to do it. Do it. Okay, like I said, I'm going to give you a number of examples that you must write. You must. Number 4, number 5. Number 5, we're going to say, she is proud of. She is proud of. We are adding reflexive pronouns to these examples I've written on the board. Meanwhile, please feel free to call on the number 0977 72 8800. I've got 4 more examples here on the board. I've got 4 more examples on the board. We're going to use a reflexive pronoun to complete the sentences. Hello, good afternoon. Hello, good afternoon. Hello, good afternoon.
I have a question. An example.
Okay, you have got an example?
Yes.
Okay, tell me your name and where you're calling from.
This is Agnes from Senanga.
Okay, please feel free and ask your question.
She swept the house all by herself.
Okay, that's an example.
Yes.
Okay. She swept.
No.
She swept.
The house
Okay.
all by herself.
The house.
All by herself.
All by.
Herself.
Correct. Okay. Okay, so you have used the reflexive pronoun. Which one is the reflexive pronoun? Herself. Correct. Okay. And then we have got a pronoun. Which one is a pronoun?
I.
She. She. Okay. So she is the pronoun and the reflexive pronoun is herself. Correct? I'm sure you understand now. Thanks for calling.
Yes.
Thanks for calling. Okay. We go back to the examples. We go back to the examples. Don't worry about this. I will fix it. Don't worry about this. I will fix it. So here we're going to supply the reflexive pronoun. Don't worry about this. Don't worry about this. I'll fix it. Okay, another caller. Good afternoon. Yes?
Hello?
Yes, good afternoon. I can hear you.
Yes, exactly. Pastor Dixon.
Sorry?
Can I speak to Pastor Dixon?
Just be clear. Can I?
Speak to Pastor Dixon.
No. Okay. You can call later. Hello, good afternoon.
Good afternoon.
Good afternoon. How are you?
I'm okay. How are you?
I'm fine. Your name and where you're calling from?
Hello?
Your name?
I'm Tuesday.
Reduce the volume. Can you reduce the volume on your TV so that I can hear you clearly?
Yes, I just want to tell you that you are running the examples. I thought after you write the example, you write on the other part, which is the paragraph.
Okay, no problem. I will not wrap the examples. I'll give you that chance to copy the examples. All right, thank you.
Yes, I'm saying if you start to write the examples, maybe you can also try to plan the other part which you are not writing.
Okay, all right.
So you will start for the example to be done.
Okay, thank you very much.
Thank you very much.
Okay. Okay, so take a note. Okay, we look at the first example. Don't worry about this. I will fix it. So the reflexive pronoun we're going to add to this example is. Okay, so the answer for example number 1 is myself. Okay, don't worry about this. I is a pronoun. Then we're going to replace I with a reflexive pronoun, myself, and it will read, don't worry about this, I will fix it myself. Okay, number 2, example number 2, the money will be ready by tomorrow, I will bring it. The money will be ready by tomorrow, I'll bring it. We must add a reflexive pronoun following the subject. Okay, the money will be ready by tomorrow, I'll bring it myself. Okay? The reflexive pronoun will be myself. Okay. Number 3, he never spoke through a lawyer, dash spoke in court. He never spoke through a lawyer, dash spoke in court. So when we're adding a reflexive pronoun, we must take note of the subject. This subject is talking about a man. Okay, so therefore even the reflexive pronoun should talk about the man. Therefore it will read, he never spoke through a lawyer, himself spoke in court. Okay, himself, here it will be himself. Himself spoke in court. So meaning it is himself that spoke in court. It is still in singular. Himself. Okay, we'll go to example number 4. Example number 4, you don't need to do it. We will do it. We don't need to do it. We will. So here we are replacing this pronoun, which is we. Therefore, the reflexive pronoun that we're going to replace must be written in plural. You don't need to do it. We will do it ourselves. So here it will be ourselves because you are more than, no wonder we say we. Okay, if it was one person, we say myself. But because there are more than one, the pronoun here is we, and it must replace by a reflexive pronoun, ourselves. Okay, we move on to example number 5. Example number 5, she is proud of herself. Example number 5, she is proud of herself. Okay, we're just writing the reflexive pronoun here, not a sentence. She is proud of herself. Okay, so that is all about examples. I'm sure by now you know when to use a singular reflexive pronoun and also a plural reflexive pronoun. Remember, we simply add the self to a singular pronoun, and we also add selves to plural pronoun. We're not talking about more than one. So if it is I, then it will be myself. It will be us, then it will be ourselves, meaning we are many. Are we together? I need to give an exercise. I hope people have copied the examples here. You're able to copy the examples for the sake of revision. During your own time, you go through your work and construct your own sentences using the reflexive pronoun. Okay, so I'll read out a few reflexive pronouns that you can use in your daily life to construct sentences. Okay, so I'll read out a few reflexive pronouns that you're going to use to construct sentences even on your own. Okay, so we've got herself, yourself, myself, yourself, ourselves, himself, ourselves, myself, itself, themselves, himself, ourselves, myself, herself. Okay, those are a few examples. There are many depending with the pronoun. The pronoun you are using in the subject sentence, or the subject, what you are talking about in the sentence is what we call the subject sentence. So it depends with the pronoun. Then when you look at the pronoun, then you will know which reflexive pronoun to use and also which reflexive pronoun to add. Are you going to use a singular or plural? Remember, singular it's myself, plural it's ourselves. Singular it's self, then plural it's the selves. Okay? Questions? For inquiries, there's a number on the screen there where it's written inquiries. You can construct your own sentences and submit. Construct your own sentences and using the reflexive pronouns and submit to that number where it is written inquiries, and we'll be able to answer and give you feedback. Hello? Hello? Hello, good afternoon. Hello, good afternoon. Hello, good afternoon. Okay, so for today we're going to end our lesson here. During your spare time, please construct your own sentences. Construct your own sentences. Okay, so we'll take this as a homework. Construct your own sentences. Okay, this will be your homework. You should submit this homework to the number where it says for inquiries. You submit and then we'll mark and resend the answers. Homework. Okay, so the homework will require you to construct at least, okay, 10 sentences using the correct, okay, so we'll say using the following. The following reflexive, pronouns. Okay, 1, you can use herself. Okay, 2, you can use myself. 3, you can use themselves. Then 4, you can use ourselves. 5, you can use himself. Okay. 6, you can use itself. Okay. 7, you can also use, okay, you can use them, themselves, them. Okay, so you can interchange as long as you construct 10 sentences. When you construct those 10 sentences, there's a number on the screen which is written inquiries. You can send those answers to that number through WhatsApp. We'll be able to mark your work. Remember, you use self when you're talking about singular, then selves when you're talking about plural pronoun. Okay, so we'll end our lesson from here. For today, we'll end our lesson from here. When we meet next time, I'll first look at those questions you're going to send. Those are able to send. Okay, until that time, this is your teacher, Madam Kayuni. Enjoy your day. Good
afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our algebraic expression.
Second lesson of the term. The lesson is coming from the same topic, basic map reading techniques. Now, before I go further with today's lesson, I would like to tell all of you learners that the answers concerning last week's exercise, where I asked you to define the term geography and also to distinguish or to differentiate between the maps and the diagrams. So for the maps and diagrams, just refer to the same differences that we had. Whereas for the term geography, you can simply say it's the study of man and his environment. If you are not satisfied, simply say it's the study of Earth. I'm sure it's simple because last week I gave definitions. Now, a continuation of the same topic, basic reading, basic map reading techniques. Let us start with what we call direction indicator. You see, cartographers have got a lot of work to do. They need to direct you where each place on the map that they draw is found. And so, whenever they are drawing what we call good maps, according to the characteristics that we looked at last week, they must indicate with an arrow. They always give an arrow like this. This arrow points to letter N. Now, some people, it's up to you, the map reader, to know that this N represents north. Because the job of cartographers is to indicate the direction of where each place marked on the map is supposed to be found. So, with this N, then they also have to do something which we call cardinal points. It's the work of cartographers. Now, cardinal points, these points are simply the so-called, they come from this word which I will write for you in capital letters. The word news. News, the N for north, the E for east, letter W for west, and letter S for south. So as you can see, we have got all these four letters here, which represent the cardinal points, the most important points which must be taken note of by all of us on the globe, across the entire world. Now, away from that, I want us to also look at, I know you must see this news, N for north, letter E for east, we're talking of directions, letter W for west, and letter S for south. Now, these other points, like the point between the north and the south, let me do it this way. I'll sketch so that you know. The cardinal points N, there is S, there is E, and we also have W. Now there are points again which lie between these cardinal points. These points lying between these two. For example, any point which is lying between N and A, we call this point as the northeast, and A. This point which is lying between south and the west, it is what we call southwest, SW. So when you see things like this, don't get surprised. Again, between south and east, the point which is lying between that is called southeast, as I'm just writing here. There is another point between the northern part of the globe and the western part of it. So I'll do this. This is north, west. Okay. So these are not cardinal points. The cardinal points are these four, which we give, which give us the word news. So the north, the east, the west, and the south are the cardinal points. But these are not cardinal points. They are intercardinal points. They are between the cardinal points or on the globe. Let us go to today's thing. We have what we call grid systems. We'll start from there, having looked at the cardinal points. we have got the grid systems. The grid systems are very important to be taken note of. Number one, when you reach what we call grid systems, you need to know what a grid pattern is or what grid patterns are. Okay, in short, what is a grid? Someone might ask you a question because we have got charts here which must be used. But before we use those charts, I want us to go to the so-called grid systems. When I explain on the grid systems, then I shall give you now what each map means here. Because all the charts here, the two charts that I've stuck here on the board are important for today's lesson. So you class learners wherever you are, please pay very much attention. A grid could be defined as a pattern of lines that cross each other, forming the rows from side to side, and also the columns from top to bottom. Don't worry, a grid, I'll write for you, is a pattern. A pattern, it's not just written anyhow. It's a pattern of lines that cross each other. That cross each other. Forming rows from side to side, and columns from top to bottom. Columns from top to bottom. Okay, don't worry, I'll make you understand what we mean by these things. The rows, the columns, don't you worry. I will explain better from the charts. Now, apart from this, we also need to know what a grid system is. Now, a grid system is something that we use to describe, okay? We use a grid system to describe the position of any point within the grid. So, a grid, it's also important that you take note of this. Please take note of these things. A grid system, is used to describe the position of any point within the grid. Within the grid. Okay. This is how we go. Now, there are many different systems for naming and numbering a grid pattern. But all good maps use at least one of these systems. Okay? So it is also important as we are using the grid system to place or to identify or describe the position of any point, it is very important for us map users to take note of the starting place or the starting point. You should not just use these grids without knowing where it is beginning or the beginning points. So now, what do we call these beginning points that we use in the so-called grid systems? These places or these points where the grid systems begin from are known as the points of origin in general. If it's in plural, it is simply known as the point of origin. So I'll write for you, don't worry. So we are going to say it is important to know the starting place. The starting place or points. For reading the grid reference. Some people may ask you to say, what do we call these starting points? Or what do we call this starting place in singular for reading the grid reference? Just tell them that it is known as, or it is called, the point of what? The point of origin. Known as the point of origin. Wow. So this is the name. Now, having looked at this, there are three things that I want us to talk about. We have moved another step ahead. Before I put my writings under these words I've written here or sentences, let us try to see the chart on the top here, color white here. This chart, which is showing, of course the two are showing the maps of Zambia, or simply map of Zambia. Now I want us to take note of this one, the first one for now. If you can see here, there is a point which is in dotted form. This is the point of origin, and that's exactly what I mean by this. Whenever you are using the grid reference, you as the map user or as someone who is reading the grid reference using the grid systems, you have to take note of the beginning or the starting point of that grid reference of yours. So in this case, as our example here, we are using this one as the starting point, which is called the point of origin. I'm very sure you have taken note of something. Then, before I give you the name of this chart, I would also like to tell you, to take you back. I mentioned the names rows and columns. Now, using this map, these lines which are going this way, the lines which are going this way on the horizontal, these. If I point like line F here, like this, moving along letter F here, again letter E. So this is row number 1, this is row number 2, whichever way, if you want to begin from there, it doesn't matter. This is row number 3, this is row number 4, this is row number 5, and this is row number 6. Then, from bottom to top, or top to bottom, like I explained, this is column number 1, this is column number 2, this is column number 3, this is column number 4, and this is column number 5, then column number 6. That's exactly what I meant when I said the so-called grid, it is a pattern of lines that cross each other. So you can see these lines are crossing each other. For example, this line, when it reaches here, it crosses another line which is coming like this. So because they are crossing each other, upon crossing each other, these lines are forming what we call the rows. The rows are formed from side to side, side to side. Whereas the columns are formed from top to bottom or bottom to top. I'm sure class learners, you are following me suit. Now, this map, as you can see, this is letter N, which represents the north, as I said earlier, because the beginning is here. It doesn't matter where you begin from, but how do you begin? That's what matters. Yes, we know that the point of origin is what we mean by the starting point whenever we are dealing with grid reference using the grid systems. Now, how do you begin? Where should the starting point be? Okay, the starting point has got two places where it should be found. It could either be placed on the top left corner, this top left corner. Then you can also put it on the bottom or at the bottom left corner. It doesn't matter, but it should be on the left side. I'm pointing. It could either start from here or from here. That's what we mean. So please take note. Don't use the top right corner or the top bottom right. The top right corner or the bottom right corner. These two are not applicable for the starting point or the point of origin. The only 2 points where we can place the starting point or the point of origin could be either the top left corner or the bottom left corner. I hope and trust we are following each other. Now, what do we call? What do we call this kind of a map? It has got a very good name. Okay? If you can see clearly, it's written alphanumeric grid reference. So now, why do we call it? Why do we call it by this name, alphanumeric? Okay, it's simple. It is called alphanumeric reference, grid reference, because it is using a combination of both numbers and letters. And of course, maps of this nature or references, grid references of this nature, we always use the letters to begin. So, for example, look at where Lusaka is. So when using alphanumeric grid reference, you always begin with a letter. So let us get some help. Let's see where Lusaka is found. Alpha numeric grid. You can refer to this chart. So Lusaka is okay. We should first follow which letter, which row. Where is Lusaka found in terms of row? So we go to F. Inside this row, Lusaka is not there. But if you go to the second row where we find the letter E, is where Lusaka is based. So Lusaka is found on E. Then in which column? Column number 1, number 2, number 3, but number 4. So Lusaka is E4. Alpha numeric grid reference. That's how it applies. Just like here. For Lusaka, we have this. Don't be surprised to say, why have they used this E? It is because this chart is combining, this grid reference is combining both numbers and letters. I hope and trust you are following me suit. Thank you so much. Maybe I can give you just a small clue. Then, it doesn't matter whenever you are writing this kind of a chart to use, maybe, if you don't want to write the letters this other side, it doesn't matter. For as long as you have indicated them here, someone who does understand what grid references are, would know to say, okay, exactly this is what this person means. Also for the numbers, it doesn't matter, either you just show them on top here and not there. Someone who is a geographer, who understands geography better, would know to say, oh, if this is a 1, then even here it's a 1. This is a 2, here it should be a 2, and so on and so forth. I hope and trust we are following each other. Now, having looked at this, let us also go to what we call national grid. I will erase or rub this first part. We go to what we call national grid. National grid, don't worry. National grid. Okay. The national grid, on the other hand, is based on the UTM. Okay? Based on UTM. Then, the national grid also, each map sheet, okay? Each map sheet. I hope you are able to see my handwriting. I hope you are able to read clearly. Each map sheet has a scale. I think underline with a different color. Has a scale, okay? Each map sheet has a scale of 1 to 50,000. 1 to 50,000. This is the scale that each map sheet has. Okay, and so they can be used for or to give the so-called 4 and 6 figure grid references. Okay, this is what we mean. And can be used to give four and 6 figure grid references. Okay, 6 figure grid references. Now, what is so important about these things? What is so important is that when we go to the second chart, that's where these things will be understood very, very well. You can see clearly that this one on the heading on this chart, which has got the color of green, coordinate grid reference for Lusaka. So this is not an alphanumeric. Instead, it is a coordinate grid reference for the same place, Lusaka. Why are you using Lusaka? Because we do not want confusion. We want you people who are learning out there to understand, to grasp the information which is underway here, which we are portraying here on the chart, as well as the explanation through the notes and the words of mouth. Okay, now, before we go any further, let us also write what we say, the same name that is there, which is reflecting the so-called coordinate grid reference. Okay, I'll use different colors so that you may understand that this is so, this is so. Geographic okay, geographic coordinate grid. Geographic coordinate grid. I'm using capital letters in order for all of you learners to fully see how things are written or what I'm explaining about. Yes, geographic coordinate grid. Now, this one, it caters for the whole entire world. Let us go to Lusaka, but the map of Zambia must not be ignored. If you can see clearly here, we have these points. This is 22 degrees east. Even here, this one, 22 degrees east. The top and the bottom lines, but the ones on the sides, this and that, I'll read them for you differently. This one is 24 degrees east. This one is 26 degrees east. This one is 28 degrees east. This one is 27 degrees east. And this one is 30 degrees east. The other one, 32 degrees east. The last one is 34 degrees east. We go to these. The horizontal lines. This is, I'll start with the north. Okay, it's fine, don't worry. But let me start from the smallest. This one is 8 degrees south. I guess we don't have the north, so it's taken from the two sides. Because if we are to draw the entire world, we can see that we should have, here we just had east, we should also have the west in terms of longitudes. Then for the latitudes, which I am about to read to you learners, we should have the south as well as the north. Okay, don't you worry. So I'll start from the smallest figure, 8 degrees south, this one, because Zambia in general is on the southern part of Africa. 10 degrees south, 12 degrees south, 14 degrees south. Then between 14 degrees and 16 degrees south, we've got 15 degrees south. So 15 is lying between 14 and 16. Don't worry, it has got something to explain before you. Then 18 degrees south. And lastly, 20 degrees south. It is drawn because Zambia is found there. Now, what is the point here? Why all these things? Look. We should always start with these. The south, or the rose in short. The rose, just like we did here. So the rose, where is Lusaka lying in terms of rose? It's on the 15 degrees. That is why it's written 15 degrees south. Don't forget, south is indicating which direction, which side of the world. Then there is a comma. We come to the other side now, in terms of columns, or the lines from the bottom to the top. Where is Lusaka found? This is 28 and not 27. This is 28, 29, should be 29 somewhere there. Okay, between 28 and 30, we should have 29. Yes. Okay, thank you. Okay, so even here should be 29 degrees east. Okay, so this is Lusaka is found on 15 degrees south, then 29 degrees east according to our chart here. I hope and trust you are following me suit. This is when we use coordinate grid reference. Then, geographic coordinate grid uses the lines, the so-called longitudes and latitudes. So, I can point to tell you to say these. For example, I'll rub one part because I want to be clear before I finish everything. Those who have done geography, who have reached grade 8, 5, 6, 7, 8 upwards there, you may understand what I'm going to draw here. I want to make everything clear so that my explanation could be understood. It's a sketch. It's not the final, but the sketch. I'm not using any scale. I'm drawing it with my free hands. Okay. This is South Pole. And this is North Pole. Okay. Then the center here, this is 0 degrees latitude of equator. In brackets, I'll just say equator. What am I trying to say? These are longitudes, so I'll just point at one, longitude. And this one is the latitude as I've written here. Now, what is the interest behind my explanation? If you see the so-called geographic coordinate grid, if we use this globe of this nature, you would find that the latitudes always start from 0 degrees, which is also called the equator. All the latitudes begin at 0 degrees, which is shown here. Now, what is the other name for this 0 degrees latitude? It is called the equator, which is at the center of the globe or the entire world when we draw it. Now, if you move from this 0 degrees, in terms of degrees, going to the north there, you reach that part, you will have reached the 90 degrees north. Again, if you move from this center, which is the latitude here, the equator here, we move from the center here to the south pole here, you will have reached 90 degrees south. So the south and the north, they refer to the equator in terms of latitudes. So even here, the southern directions here, the S represent the latitudes. Whereas this one, when you use the longitudes, you start at 0 degrees Greenwich meridian, the starting point there. Now, the 0 degrees Greenwich meridian, if you move from east, from this center to the east, you will have reached 180 degrees. Again, if you move from this, the center of it, which is the starting point, I will say Greenwich. Some people might wonder, what is Mr. Cheo talking about? Greenwich meridian. This one deals with the longitudes. If you move from the center here, where it starts from, to the west, you will have made 180 degrees west. Okay, because of time, let me just maybe explain just one or two things before I conclude today's lesson, because we are almost behind time. We have, in terms of this, we have explained using the chart. We are done. We come to the last part for today, scale. I'll end on the scale for today because time is not with us. Now, a scale, someone might ask that, what does a scale do? A scale simply gives the relationship between the distance on the map and the distance on the ground. Now, what do we mean here? Relation connects, it connects, if I want, distance on the map and that on the ground. On the map to distance on the ground. On the ground. What does this do? There are different units altogether. If we go deep, when I say distance on map, I mean the distance which could be drawn on these small drawings such as the paperwork. But when I say distance on the ground, I mean the real distance that someone could cover or that could be covered. That's what we mean. When you say distance on the ground, we mean real distance. Then on the map, we mean that distance which is drawn on the paperwork. There are 3 ways that you can use to give a scale. 3 ways to give a scale. 3 ways to give a scale. Way number 1, we have what we call statement of scale. Statement of scale simply uses words, okay? It uses a word or simply words to describe the relationship between the map and the ground. So statement of scale. Statement of scale. This is the last part for today's lesson. It uses words to describe the relationship between the distance on the map and that on the ground. Then we also have what we call ratio scale. This ratio scale uses only the numbers to describe the relationship on the ground to that on the map. Last but not the least is what I'm going to do here. So that we end today's session, I allow questions to be asked. Number 3, there's this line scale, which is number 3 for today, the line scale. Now, what does this do? Line scale is a line which is drawn below the map. When it is drawn below the map, what does it do? What happens is this. It shows the relationship also between the distance on the ground to that distance on the map. Now, the length, okay, the length of this line scale, which is drawn on the map here, represents the distance on the map. But the figures or the units which are labeled on the same line, they represent the distance on the ground. I'm saying the length of this line on the map represents, if for example you come to this line scale on this same chart down here, so the length, okay, on the map represent the distance on the map, but the units labeled, they represent the real distance on the ground. So these are the things that I had for you today, or this is the way I prepared for you in terms of lesson. Now that I'm concluding, or I'm done in terms of explanations, illustrations, I would like callers to reach us through the number 0977 72 80,000. Before I just finish, I've got a caller. Oh, it's a message. Okay. The number to call us on is 0977 72 80,000. Please, you are free to contribute. You are free to tell us how best you would want to be saved. I hope and trust you have followed the lesson suit. Please call us on the number 0977 72 8000. We have learned about 2-3 things here. We have learned about the grid systems. We have also learned about alphanumeric grid reference. We have also learned about coordinate grid reference. We have also learned about the scale. Okay? So now, I want us to share the knowledge. Hello? Call us on the number 0. Okay? 3 missed calls. 0977 72 8000 is the number that you can call us through. The lesson has been on direction indicators. I started from the point to say the cartographers always show direction of places, and to show very well how each place or where each place is supposed to be found, they write an arrow which points upwards on the map. That arrow, mostly it has the letter N, which represents north. Then I also touched the other points where I said we have got what we call the cardinal points. The cardinal points come from the word news. News, the letter N stands for north. Then the letter E stands for east. The letter W stands for west. And the letter S stands for south. Now, what do I mean by that? This globe, everything, where the places are found across this globe, we can use the same cartographers to identify where each place is found. I also moved on by saying whenever you are using alphanumeric grid reference, you should start with the letter, then the number. The letter represents the row, whereas the number represents the column, according to this diagram. I also came to the coordinate grid reference. I said the... Hello? Okay, let me try to read through. Okay, a shared love story. Okay, I think these are just some of the things. Hello, call us on 0977 72 8000. I will allow only 2 calls for today. Please, you can call us on the line 0977 72 8000. That's the line that you can reach us on. So as I'm waiting for 2 calls or 1, let me start just bang on, so that I make you understand everything. I'm saying this one, if you see the S, in terms after degrees, there is letter S, letter S, letter S, letter S, letter S. Now, just bear in mind that, between the longitudes and the latitudes, the ones which use the southern part or southern direction and the northern direction are the latitudes. Whereas, if you see the E, the east, the ones which use the east or the west are the longitudes. That is why I have sketched this small circle, seemingly, just as a freehand drawing. That is why it doesn't look like that one, but it's almost there. Someone can know to say this is exactly what is taking place. Okay, this has been your presenter, Chewe Webster. Till next time, bye-bye.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.
are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at our geographic expression.
Good evening, class. Welcome to Biology 11. I'm your teacher, Miss Lesa, and like I said, I'll be taking you in Biology 11. So last time we started the topic transport in man, and we said there are two transport systems. We explained that a transport system is a system of movement of a substance from one site in the body to another, or from one position or place to another. And we said that in man and other mammals, there are two types of transport systems. There's what we call a circulatory system, a blood circulatory system, and a lymphatic system. So we said we'll start with the blood circulatory system. And when we started, we said that the blood circulatory system consists of three organs: the heart, the blood, and the blood vessels. And we started by looking at the blood. We said blood is a fluid tissue that contains red blood cells, white blood cells, platelets, and plasma. Okay. So from where we ended last time, we already started looking at red blood cells and white blood cells, and we even distinguished them. So today, at the end of this lesson, we should be able to explain further on the components of blood, which is further going to platelets and plasma, and identify the functions of blood. We should be able to explain the functions of blood and finish up with identification of the components found in blood. So a recap, when we looked at red blood cells, we said these are biconcave discs that are responsible for the transport of oxygen from the lungs to the tissue cells, and they also carry carbon dioxide from the tissues back to the lungs. So we said these are biconcave and they don't have a nucleus. Okay. Biconcave discs no nucleus, and they carry oxygen from the lungs to the tissue cells. We said they are produced in large quantities or large numbers. Okay, they are small in size because about a milliliter of blood, they are 5 to 6. $5 to 6 million in a milliliter of blood. Okay. All right. So these are the characteristics of red blood cells. They are biconcave disc shaped. So this biconcave disc shape, last time I came with a chart. And their side view looks like this. Okay, so that's a biconcave disc shape. They have no nucleus. They carry oxygen from the lungs to the tissue cells and a small amount of carbon dioxide from the tissue cells to the lungs. They are produced in large numbers. About 5 to 6 million red blood cells are found in a milliliter of blood. They are produced in the bone marrow. But can also be formed in the liver of babies. They are produced in the bone marrow of adults, but can also be formed in the liver in babies. So these are the characteristics of red blood cells that we looked at. And then we went ahead to look at white blood cells. Okay. On the other hand, white blood cells are irregular shaped. They defend the body. Against infections and or diseases. Okay, they are produced in smaller quantities. compared to red blood cells, white blood cells are produced in smaller quantities, meaning that if there are 5 to 6 million in a milliliter of blood, we only find about 12,000 white blood cells in a milliliter of blood. Okay, they are produced in the bone marrow, lymph nodes, thymus, tonsils, and spleen. Okay? So for white blood cells, they are not only produced in the red marrow, others are produced in the lymph nodes, the thymus, the tonsils, and also in the spleen. Okay? So these are characteristics of white blood cells. They are irregular shaped, they defend the body against infections or diseases, they are produced in smaller amounts as compared to red blood cells. About 12,000 to 15,000 are found in a milliliter of blood. They are produced in the bone marrow, the lymph nodes, the thymus, tonsils, and the spleen. So last time I started giving a table of differences between white blood cells and red blood cells, and I said there are many. So from this classification, if you put this in a table, these can be your differences. Where there's biconcave disc shaped, those ones are irregular shaped. These ones have no nucleus. The white blood cells have a nucleus. It's actually supposed to be here. They have a nucleus, a central, large, or a lobed nucleus, depending on the type, which we looked at last time, or lobed nucleus. And speaking of types, these are of many types. Whereas there is only one type of red blood cells. They are of one type. There is only one type of red blood cells. So the whole body consists of only one type of red blood cells. Okay? Whereas there are many types of white blood cells, and we looked at the two main types of white blood cells being the phagocytes also known as macrophages, and the lymphocytes. These are the two main types. So if they are the main types, it means that there are other types of white blood cells that we have. But we looked at phagocytes and lymphocytes. We looked at phagocytes and lymphocytes, and we said that phagocytes have a lobed nucleus. Phagocytes have a lobed nucleus because they detect, engulf, and destroy bacteria, whereas lymphocytes defend the body by producing antibodies and antitoxins. Okay, so I'm saying phagocytes engulf bacteria and destroy it. Okay, these produce antibodies which destroy bacterial germs or foreign bodies and antitoxins which neutralize the poison from germs. Okay, so we said white blood cells are of many types, and the two main types of white blood cells are phagocytes and lymphocytes. Okay, so phagocytes, these identify bacteria and engulf it. To engulf is simply to enclose. They enclose bacteria and destroy it, whereas lymphocytes produce antibodies and antitoxins. Antibodies destroy bacteria, while antitoxins neutralize poisons from bacteria. So an antitoxin will just remove the poison from the bacteria, but not completely remove the bacteria or the germ. But an antibody will completely destroy the germ or the bacteria. Those are types of white blood cells. So after we looked at the types of white blood cells, and by the way, these move in the blood, while these remain in the lymph system. Remain in the lymph system, which we will look at when we start looking at the lymphatic system. So the phagocytes move in the blood. They have a movement body. From last time I gave you a shape of a white blood cell. It was irregular, and I said it moves like the way amoeba moves. It has an amoebic movement or a swimming-like movement because it swims in blood for it to be able to find bacteria or germs which are moving in the blood. So the phagocytes move in the blood so that they're able to engulf the bacteria, whereas the lymphocytes remain in the blood system, remain in the lymphatic system, producing antibodies and antitoxins which will move to where the bacteria is. So that was where we ended on white blood cells and red blood cells. So today we'll look at the two remaining components of blood. We'll look at the platelets and plasma. What are platelets? So for the question I left last time, for you to add more differences of red blood cells and white blood cells, it has been answered on the board. These are the differences between red blood cells and white blood cells. Okay, so these are fragments formed from the manufacturing of red blood cells. So when the formation of red blood cells is happening, which I said happens in the bone marrow, the fragments that remain from that formation are called platelets. Okay, so they are fragments from the manufacture or formation of red blood cells. Okay. They are from the manufacture of red blood cells, and their size is about a quarter of a red blood cell. So I said that a red blood cell is smaller than a white blood cell. White blood cells are bigger. Now, if a red blood cell is very small, platelets, the size of a platelet is about a quarter of a red blood cell, which means that they are extremely small. Okay? Now, their function, they are important in the process of blood clotting. Okay. So clotting is the process of stopping bleeding. Clotting is a process of stopping a bleeding or a sore from bleeding. When we stop bleeding, we are clotting. So what is blood clotting? There is a mechanism of blood clotting. What happens during blood clotting? And I've said that platelets are the tissue, are the cells in the blood which do the process of blood clotting. So I've illustrated the mechanism of blood clotting on this chart. Here we have platelets. So when platelets are exposed or introduced to, are exposed on a damaged or injured tissue, they produce an enzyme called thromboplastin or thrombokinase. Thromboplastin or thrombokinase, that's the other name for thromboplastin. This thromboplastin enzyme catalyzes the breakdown of a plasma protein called thrombin, prothrombin, this one. So this thromboplastin catalyzes the breakdown of prothrombin, which is an inactive plasma protein, to make it into thrombin, which is an active form of plasma protein. Okay, so it breaks down, thromboplastin breaks down prothrombin into thrombin. It aids the breakdown of prothrombin into thrombin, because prothrombin is an inactive plasma protein, but thrombin is an active form. And this reaction takes place in the presence of vitamin K. So thromboplastin and vitamin K aid the reaction or the conversion of prothrombin to thrombin, which is an active form. This thrombin acts as an enzyme and also aids another reaction. It also catalyzes the formation of fibrin from fibrinogen, which is another plasma protein, but this one is soluble. Okay, so when thrombin is formed, it catalyzes the reaction of conversion of fibrinogen to fibrin. Fibrinogen is a soluble plasma protein, but what we want in the process of blood clotting is an insoluble protein. We don't want a soluble protein. We are looking for an insoluble protein. So we have to catalyze this reaction, and thrombin is needed in its active form to catalyze the reaction of conversion of fibrinogen to fibrin in the presence of calcium ions. So calcium ions and thrombin convert fibrinogen from its insoluble form to fibrin, which is from its soluble form to fibrin, which is an insoluble plasma protein. So when it is insoluble, it simply means that it cannot dissolve. Okay, it cannot dissolve. Thereby, it will form a network of fibers over the wound. We are talking about an injured or damaged tissue. So I'm simply talking about a cut on your body. Say you cut yourself with a knife in the kitchen, or you have a sore, you fell down and you injured yourself. These platelets produced thromboplastin or thrombokinase, added it to vitamin K and aided the conversion of prothrombin from its active form to thrombin, which is an active form. This thrombin will further convert fibrinogen to fibrin in the presence of calcium ions. They will convert fibrinogen, which is an insoluble protein, to fibrin, which is a soluble protein, to fibrin, which is an insoluble protein. And this insoluble protein will make a network of fibers over your wound, causing a network of fiber which is called a mesh. So this mesh is formed over your wound and it traps red blood cells, leading to the formation of a blood clot, because the network of fibers has become like a net, a fishing net. When you form a net over a bleeding wound, it will stop bleeding, and that will cause a blood clot. So that is how the mechanism of blood clotting takes place. That is the mechanism of blood clotting. So when that blood clot is formed, the mesh will later heal into a scrub. From a scrub, then it will form a scar, and the wound is finally healed. Okay, so that is the process of blood clot or blood clotting. So what is the importance of these platelets? Apart from being involved in the process of blood clotting, platelets are important because okay, apart from one which we've already said, they're important in the process of blood clotting. They prevent, because they make blood to clot, they prevent excessive loss of blood. Prevent entry of bacteria or germs into the bloodstream. Okay, and the process of blood clotting is the first step to healing, so they cause the first step to healing. First step in wound healing. Okay, because after a blood clot, a mesh is formed. I mean, when the blood is clotting, a mesh is formed. The mesh further forms a scrub, which when it dries off and falls off, a scar will be formed over your wound. So platelets are important in the process of blood clotting. They prevent excessive loss of blood. They prevent entry of bacteria and germs into the bloodstream, because exposure of a wound to a contaminated environment will cause entry of bacteria or germs. And we know that that wound is exposed. You are bleeding. So when germs enter your blood, they will go direct to your bloodstream. So they prevent entry of germs and bacteria into the bloodstream. And they're the first step. They cause the first step to wound healing. So they cause the first step in healing. Okay, so we'll now look at plasma. The last component of blood. Blood contains these four components. We've looked at red blood cells, we've looked at white blood cells, we just looked at platelets, and now we'll look at plasma. Okay, so this is the liquid part of blood. It is the liquid part of blood. Okay. Which is mainly water and dissolved substances. This is the liquid part of blood, which is made up of water and dissolved substances. It is the liquid part of blood. Blood is a liquid. When you bleed, you see a liquid coming out. So that liquid consists of 4 components. We've removed out the red blood cells, we've removed the white blood cells, the plasma, and now we are left, the platelets, and now we are left with the plasma, which is the liquid part of blood that is made of water and dissolved substances. These dissolved substances are food substances, okay? Now these are dissolved, so the process of digestion has taken place. Now when assimilation takes place, you are told that the breakdowns of carbohydrates, proteins, fats, mineral salts, and vitamins are assimilated into your body. They are taken into the bloodstream. They diffuse into the bloodstream to be used by the body. So these are the food substances that I'm talking about that are in the plasma. So in addition to water, these food substances are, we have amino acids, which are the breakdown of proteins. We have monosaccharides, the breakdown of carbohydrates. Monosaccharides, lipids. The breakdown of lipids is fats, fatty acids, and glycerol. Which you learnt in grade 10. These breakdowns you did in grade 10 under the topic digestion. Mineral salts, and vitamins. So these are the food substances that are found in plasma that we are obviously moving from the small intestines to the tissue cells, because digestion has taken place. We need to assimilate them. So these are found in blood. Then we find gases, oxygen and carbon dioxide. Of course, oxygen in the form of oxyhemoglobin, because last time I said that red blood cells contain a red pigment called hemoglobin, which binds to oxygen to form oxyhemoglobin and carry it. So oxygen is carried in the form of oxyhemoglobin by the blood. So I said, if there is a large supply of oxygen at a certain place in the body, for example, the lungs, because we know when we breathe in, oxygen first goes to the lungs. So in the lungs, there is a high supply of oxygen, and there is a low supply of oxygen in the muscles. So oxygen will bind hemoglobin and be moved down to the muscles, where that oxyhemoglobin product will dissociate back into hemoglobin and oxygen. So oxygen is carried in the blood plasma as oxyhemoglobin. Carbon dioxide is also carried in the blood from the tissue cells to back to the lungs for purification. So the blood carries carbon dioxide out of tissue cells back to the lungs. Okay, and that's why you breathe out carbon dioxide. Okay. What else is found in, apart from, we find waste products. So under digestion, you said that the waste products of food are taken out through the excretory system. So we have urea found in urine, poisons and toxins, okay. All these are waste products. Plasma also carries hormones. So hormones are also the dissolved substances found in plasma, which you will look at when you do endocrine glands, hormones, and also heat, okay? When heat is formed in the body, it is carried in blood plasma. When heat is formed in the body, it is carried throughout the body in plasma, okay? So plasma carries dissolved food substances, gases, waste products, hormones, and heat. Dissolved food substances, we have amino acids, fatty acids and glycerols, monosaccharides, vitamins and mineral salts. On gases, we have oxygen and carbon dioxide. Waste products, we have urea, we have poisons and toxins. When you take in poison, it is an excretory product. It is carried in your blood, hormones, and also heat. So blood is important also for heat transfer. Okay, so when you want to keep warm, heat is carried in the blood. Okay, heat is carried in the blood. So for today, the last thing we're going to do is just identify the functions of blood. Having looked at all the blood components, what are the functions of blood? Some of which we can even get from the functions of each component of blood or the characteristics of each component of blood. Some of those are also functions. Okay, so one, it carries or transports. So there are two basic functions of blood. It's for transport and also for heat transfer. By transporting, it transports oxygen, from the lungs to the tissue cells, carbon dioxide from tissue cells to the lungs, transports food substances dissolved food substances from the small intestines to the tissue cells it also transports waste products from the tissue cells to excretory organs. Okay? Excretory organs like the liver, kidneys. Okay? So blood transports oxygen from the lungs to the tissue cells and carbon dioxide from the tissue cells back to the lungs for purification. It also transports dissolved food substances from the small intestines to the tissue cells where food is needed, and transports waste products from the tissue cells to the excretory organs. It transports hormones from ductless glands or endocrine glands. You look at hormones under the endocrine system. Endocrine, from the endocrine or ductless glands to target organs. And also transports heat formed from the process of respiration to all parts of the body. So when I said transport is a process of moving something from one place to another. So when you talk about transport, you should be able to identify the organ or the part of the body where something is moving to the part of the body where it's going to. So here, oxygen is moving from the lungs to tissue cells. Carbon dioxide moves from the tissue cells to the lungs. Food substances move from the small intestines to the tissue cells. Waste products are being removed from our cells to excretory organs for excretion to take place. Hormones move from endocrine glands to target organs, and heat moves from respiratory organs to all parts of the body. Okay? To all parts of the body. All right, so these are the main functions of blood. These are the main functions of blood. Okay, these are the components of blood that we have discussed, and these are the functions of blood. So having identified the components of blood and explained the functions of blood, next time we'll be looking at blood groups and blood disorders. We'll look at blood groups and the disorders of blood. But for today, I'll leave you with a question. I'll leave you with a question. I'll leave you with a question. And if you have a question, you can SMS me on the number scrolling on your screen. Okay? Okay. The diagram below shows the blood of a mammal. I'm taking SMSs and cause shows the blood of a mammal. State three ways in which the white blood cells differ from the red blood cells. B, draw a different view of a red blood cell from the one given above. Okay, so last time I came with a chart showing the different views of a red blood cell. I brought a side view and a front view. So today the question says draw a different view of a red blood cell from the one given above. The diagram below shows the blood of a mammal. That's the diagram. State three ways in which white blood cells differ from red blood cells. B, draw a different view of a red blood cell from the one given above. So I'll just check your SMSs. Okay, someone says, Madam, we are unable to see the things which are at the bottom of the board. Sorry about that. Okay. All right. So I'll be taking questions on blood, questions on blood. Questions on blood. All right. What I have a missed cause, sorry about that. Calls and SMSs, maybe I'll just wait for one. As I do a recap, blood consists of red blood cells, white blood cells, plasma, and platelets. Red blood cells carry oxygen from the lungs to tissue cells and carbon dioxide from tissue cells to the lungs. White blood cells defend the body. There are many types of white blood cells. The main types are phagocytes and lymphocytes. Phagocytes engulf bacteria, whereas lymphocytes produce antibodies and antitoxins which destroy bacteria and neutralize poison from germs or bacteria respectively. Okay, platelets are fragments formed from the manufacturing of red blood cells and they help in the process of blood clotting. In the process of blood clotting, I said that when platelets are exposed to a damaged or injured tissue, they produce an enzyme called thromboplastin or thrombokinase, which in the presence of vitamin C catalyzes the reaction of converting prothrombin, an inactive form, to thrombin, which is an inactive form of a plasma protein. This thrombin also, in the presence of calcium ions, catalyzes the breakdown of fibrinogen, a soluble plasma protein, into fibrin, which is an insoluble plasma protein. This insoluble protein will form a network of fibers over a wound called a mesh. This mesh will trap red blood cells and thereby causing a blood clot. The mesh will later form into a scrub which will dry and fall off and cause a scar. That is the mechanism of blood clotting. Platelets are important because they prevent excessive loss of blood. They also prevent entry of germs and bacteria into the bloodstream, and they are the first process of healing. Okay, plasma is the liquid part of blood which is mainly water and dissolved substances. Water and dissolved substances, which are food substances from breakdowns of digestion. We have waste products, heat, and we also have hormones. Okay, plasma consists of food substances, gases, waste products, heat, and hormones. So if there are no calls and SMSs, okay, if there are no calls and SMSs, okay, we'll end our lesson here. I've given a question. We'll look at this next time when we look at blood groups and blood disorders. I've been your teacher, Miss Lesa, taking you in biology grade 11. Thank you. Till next time.
Good afternoon, class.
And these are examples of crops that we grow in Zambia and the livestock.
Look at algebraic expression.